Okay, in this video I'm going to solve a larger system, one with 3 equations and 3 variables. So there'll be a lot more row operations that we have to complete here. The augmented matrix, first of all, looks like this. I have 1, -2, 1, and then 0. A 0 in the first position because notice x1 is missing from the second equation. 2, -8, and 8. And then the third equation, -4, 5, 9, -9. So here is the augmented matrix. Now, notice in the top position here, we already have a 1. So we don't have to do any row operation there for that. Underneath it, there's already a 0, so we don't have to do any row operation there. But down here, there's a -4, and we would like to add 4 to that position to turn that into a 0. So I'm going to take row 3, and I'm going to add 4 times row 1 to get the new entries in row 3. First row stays the same. Second row stays the same. And the third row I'm going to change using this row operation. So I have 4 times 1 plus a -4, that's 0. 4 times -2, that's -8 and 5, -3. 4 times 1 is 4 and 9, gives me 13. And 4 times 0 is 0, plus a -9 gives me -9 in that spot. Now I go to the next column, and on the diagonal I see a 2. I need that to be a 1, so the operation is going to be 1/2 row 2. I'll try to squeeze that in here. 1, -2, 1, 0. Second row, I'm multiplying everything by a half. 0, 1, -4, and +4 will go there. Third row stays the same. 0, -3, 13, -9. And we scoot over there just a little bit. So there's the matrix now, and I have a 1 on the diagonal in the second column. Okay. Alright, so below that 1, I'm going to need to make a 0, and my row operation will be row 3 plus 3 times row 2, because that's where I just put the 1. So the second row that I'm using in this calculation, where I just put that 1, I'm going to multiply every entry by 3 and add it to the row below, row 3. So 0 plus 0. 3 times 1 is 3, and -3 gives me a 0. 3 times -4 is -12. And 13 gives me a 1 right there. And that's great because I'm going to want a 1 there in the next step. And 3 times 4 is 12, plus -9 gives me 3 in that position there. Okay. In the second column above the 1, I have -2. In order to make that a 0, I'm going to take row 1 and add 2 times the row 2 entries to turn that into a 0. So in row 2, I have a 0 times 2 plus 1. I have 2 times 1 plus -2. That gives me 0. 2 times -4 is -8, and 1 gives me -7. 2 times 4 is 8, and 0 gives me 8 right there. So now you can see the first column and the second column are in the proper form. I'm now going to go to the third column. Notice I already have a 1 on the diagonal. So I now just have to make zeros above it. 2 row operations and I'll be done here. First of all, to change the second row, I'm going to take the second row and I'm going to add to it 4 times row 3. Okay, row 3 is where my 1 is. So I'm going along row 3, multiplying by 4 and adding it to the entry above. So 4 times 0 plus 0, 4 times 0 plus 1, 4 times 1, that's positive 4. Negative 4 gives me the 0. And this calculation I have to be careful of. 4 times 3, that's 12. And 4 more is 16 in that spot right there. And finally, in this position, I have a negative 7. In order to make that a 0, I'm going to take row 1 and I'm going to add 7 times row 3 in order to make that position a 0. So running across row 3, I'm going to multiply each entry by 7. 7 times 0, that's 0, plus 1. 7 times 0 is 0, plus 0. 7 times 1 is 7, and negative 7 gives me a 0. 7 times 3 is 21, plus 8 gives me 29. And now I have diagonal form. I'm at the end of the problem, and I can see my solution is x1 is 29, x2 is 16, and x3 is 3. There's the solution to my original system, and if you replace the variables x1, x2, and x3 with these 3 numbers, 29, 16, and 3, it will satisfy all 3 of those equations in my system.